How did they build in the Middle Ages without modern tools? We look at the majestic cathedrals and impregnable castles that have come down to us from the depths of centuries and ask ourselves, how? We are used to thinking that progress is a linear movement from simple to complex, from primitive to perfect. But when it comes to medieval construction, this certainty begins to waver. Their methods conceal a logic and genius that we are only beginning to rediscover. The basic philosophy and principle of the peasant house was extremely simple and rational: to make maximum use of what the land beneath their feet in a given area generously provided. It made no economic sense to transport expensive hewn stone hundreds of kilometers by cart when there was an abundance of accessible forest and clay deposits right nearby. To do this, builders would go to a nearby forest and find two large trees with a natural arch in their trunks, carefully cut them down, and saw them in half lengthwise with a special saw. This resulted in two almost mirror image curved halves of the same tree, which, when skillfully joined at the top with a cross beam, formed a perfect sturdy A-shaped arch without a single nail. The natural shape of the tree was used to maximum effect, providing natural strength to the structure without complex processing. These massive wooden truss arches became the main supporting skeleton and foundation of the entire house, on which the rest of the structure rested. They were securely placed on a shallow stone foundation to protect them from rot and rigidly connected to each other with longitudinal, horizontal beams to form a frame. The walls of a peasant house were a truly remarkable work of folk art, admirable for their resourcefulness and environmental friendliness. The space between the vertical beams of the wooden frame was carefully filled with a woven, flexible structure made of thin willow or hazel rods, traditionally called a wattle. This woven plant shield was then thickly coated on both sides with a thick layer of a special mixture of local clay, crushed straw, river sand, and domestic animal manure. The so-called adobe or daub, creating a solid wall. This technology has been used for thousands of years and has been perfected by many generations of builders. Such a multi-layered wall was incredibly cheap to build, practically free, retained precious heat in winter thanks to its thickness and porosity, and breathed naturally, effectively regulating humidity in the room without mold. In summer, such a house with thick walls was pleasantly cool even in the heat, and in harsh winters, it was relatively warm with minimal heating. In case of mechanical damage, any section of the wall could be easily and quickly cut out and replastered by hand, using the same affordable local materials without hiring specialists. Repairs did not require significant costs and could be carried out by the homeowner himself in a day. The roof of the house was most often traditionally covered with dry rye straw or durable reeds from the marshes, carefully laid in a very thick, dense layer, several tens of centimeters thick, using a special technology. Such a plant-based roof was not only completely waterproof when laid correctly, but also served as an excellent natural insulator, retaining heat. When laid correctly and professionally with overlapping layers and regular maintenance and renewal, it could serve reliably for several decades without complete replacement, which made it economically advantageous. A thatched roof was also lightweight, which reduced the load on the frame of the house and did not require strong supports. The floor in the simplest and poorest peasant houses was usually earthen, well-trodden to hardness, and sometimes covered with a fresh layer of clean straw for extra warmth, softness, and relative cleanliness. The windows in the house were deliberately made small and narrow to maximize heat retention and reduce heat loss, and were securely closed at night with wooden shutters to keep out the cold. Expensive glass was almost never used in the windows of peasant houses It was an unaffordable luxury reserved exclusively for wealthy townspeople and the nobility. Instead of glass, oiled paper or ox bladders were sometimes used to let in light, but they were fragile and short-lived. Thus, a typical peasant house was almost entirely biodegradable and consisted exclusively of renewable natural resources without synthetics. It literally grew out of its native soil, using its gifts, and, in the event of prolonged abandonment and destruction, naturally returned to it over time without a trace. The process began with digging a huge pit or trenches for the future walls. This was one of the most labor-intensive tasks, performed manually with shovels, pickaxes, and hoes. The earth was carried away in wheelbarrows or carried in baskets. The depth of the foundation depended on the scale of the building and the quality of the soil. For massive stone cathedrals, the pits could go many meters into the ground until the workers reached a solid, load-bearing layer, rock or dense clay. If the soil was weak and swampy, they had to resort to tricks. In such difficult conditions, for example, when building in Venice or Amsterdam, hundreds or even thousands of wooden piles were driven into the bottom of the excavation pit. Oak or larch was usually used, as the wood of these species does not rot in water. The piles created a solid foundation that evenly distributed the weight of the building on weak soil. The foundation itself was laid on the prepared base. It was made of the strongest and heaviest stone that could be obtained. The stones were laid dry or fastened with lime mortar, trying to minimize voids. The width of the foundation was always significantly greater than the width of the future walls. This created a stable base that prevented the walls from walking and cracking under the enormous weight. The rule was simple. The higher and heavier the wall, the wider its underground roots had to be. Builders also paid great attention to drainage. Special ditches filled with gravel were laid around the foundation to drain rainwater and groundwater. Excess moisture could erode the soil and weaken the entire structure, so it was combated from the very beginning. The quality of the foundation was a matter of honor for the Masons Guild. Not only their reputation depended on it, but also the lives of the people who would be in the building. Therefore, at this stage, no effort, time, or materials were spared. The basis of absolutely all medieval wooden structures, from simple peasant barns to the most complex multi-tiered roofs of majestic cathedrals, was an ingenious, centuries-old system of durable tongue-and-groove joints that did not require metal. Medieval carpenters and craftsmen brought this ancient art of joinery to absolute perfection and virtuosity through generations of knowledge transfer. They understood deeply from practical experience that metal nails and staples inevitably rusted over time due to moisture and were extremely expensive, while a properly made wooden joint with a precise fit only became stronger over time due to the shrinkage and swelling of the wood. As the wood dried and shrunk, it compressed the joint even more tightly, making it virtually inseparable and increasing its strength with each year of service. The most common and versatile was a basic joint called a half-tree notch, which was used everywhere in construction. In two beams to be joined exactly at the point of their intersection at a right angle, half the thickness of each beam was carefully cut out with an axe and adze, creating flat surfaces. When the processed beams were placed on top of each other with these notches, they formed a perfectly flat, uniform plane without protrusions, and were firmly mechanically connected to each other by friction and mutual pressure. This joint was simple to execute but very reliable for most structures and could withstand significant loads without deformation. For a strong connection of massive beams at right angles, for example, when assembling the vertical walls of a half-timbered frame house, or when creating frames, a more complex tenon in an open groove connection with a precise fit was widely used. A rectangular protrusion of a strictly defined size, a tenon, was skillfully cut out at the end of one beam, leaving it protruding. A corresponding recess or groove was carefully carved into the side surface of the other beam with a chisel, checking the accuracy. The accuracy of the fit was critical to the strength of the entire assembly and required the experience and patience of the craftsman. The carved tenon was inserted tightly with force into the prepared groove, creating a strong corner joint capable of withstanding heavy loads. To make the structure even more reliable and prevent the joint from coming apart over time, the connection was additionally secured mechanically. To do this, a through-round hole was carefully drilled with a drill bit in the already assembled and fitted joint, and a special wooden nail, a dowel, was hammered into it with force, wedging the joint from the inside. The dowel passed through both parts, firmly fastening them together and preventing them from coming apart even under heavy loads. Nails were traditionally made from hard, durable woods, such as oak or ash, which did not split. They were slightly conical in shape, tapering towards the tip, which allowed them to be driven very tightly into the hole with tension, creating a wedge. For more complex and critical structural joints, such as when attaching sloping rafters to load-bearing horizontal roof beams, hidden and more complex joints were used, requiring skill to make. One such classic joint was the famous dovetail, considered a sign of high craftsmanship. This ingenious joint was self-locking due to its geometry and worked only in tension, preventing the parts from coming apart. Due to its shape, it was practically impossible to disassemble it without destroying or splitting the wooden parts completely. This ensured the highest strength, reliability, and durability of the entire structure for centuries, which was critically important for critical components. The dovetail was used in the most heavily loaded and important joints, where failure was unacceptable. The work required incredible precision of eye and hand from an experienced carpenter. Even a gap of a few millimeters could critically weaken the entire joint and lead to its premature destruction under load. The skill of a carpenter was determined precisely by the accuracy of the joints, which could only be achieved after many years of practice. Assembling the wooden frame of a house was like working with a giant three-dimensional construction set made up of many parts, requiring the coordination of a team. The frame elements, carefully prepared and fitted on the ground, were lifted up with blocks and ropes and joined in a strictly defined order according to the master's plan.
We should have this ready by
Each connection was carefully thought out and executed with such precision that the forces within the entire structure were distributed evenly across all elements without overloading individual parts. Understanding the distribution of loads was intuitive, based on the experience of generations of builders. As the walls of a castle or cathedral rose higher and higher, builders faced a major problem: how to get multi-ton stone blocks and massive wooden beams to the top. The solution to this problem was one of the most impressive achievements of medieval engineering. In the early stages of construction, simple earthen ramps or embankments were used. As the walls grew, the embankment was also filled in and lengthened, turning it into a gentle road along which oxen could pull sleds with stones to the top. This method was effective but required a huge amount of earth and labor. When the height became too great, lifting mechanisms came into play. The simplest was a conventional winch, a log with handles onto which a rope was wound. This device allowed several workers to lift small loads. For really heavy blocks, a more serious machine was needed. And that machine was a large lifting crane with a squirrel wheel. It was a huge wooden structure resembling modern cranes, but with one key difference. The crane was not powered by a steam engine or electricity, but by human muscle power. One or two huge wooden wheels, several meters in diameter, were installed at the base of the crane. Workers walked inside these wheels like squirrels. Stepping on the internal crossbars, the people turned the wheel with their weight. The wheel, in turn, rotated a drum via an axle, onto which a lifting rope was wound. This system, which worked on the principle of a lever, allowed 2 or 3 workers to lift loads weighing several tons to a great height. These cranes were installed directly on the walls under construction or on the upper tiers of scaffolding. They were collapsible, and as the building grew, they could be moved higher and higher. The work inside the squirrel wheel was monotonous and exhausting, but it was this work that made it possible to erect the walls of Gothic cathedrals. These giant wooden machines were the pinnacle of construction technology of their era. They were slow, creaky, and completely dependent on human endurance. But it was they that allowed the people of the Middle Ages to reach for the sky and build buildings that still amaze with their height. But what held the stones in these walls together, making them a monolith? The strength of masonry depends not only on the quality of the stones, but also on the mortar that binds them together. Medieval builders did not have modern Portland cement, but they created their own surprisingly durable binding material. The basis of this mortar was lime. The production process began with the extraction of limestone. Like building stone, it was mined in quarries. The limestone then had to be burned to turn it into quicklime. For this purpose, special furnaces were built, similar to large stone wells. The furnace was tightly loaded with pieces of limestone and firewood. Then the firewood was set on fire, and the burning process could continue for several days at a temperature of about 900 degrees Celsius. After burning, the limestone turned into fragile, light pieces of quicklime. It was a very corrosive and dangerous substance that had to be handled with great care. The next step was to slake the lime. Quicklime was poured into water in special pits or vats. A violent chemical reaction began, releasing a large amount of heat, hissing, and steam. The result was slaked lime, or pushonka, a plastic, paste-like mass. This lime was left to mature in pits for several months and sometimes years. It was believed that the longer the lime matured, the higher the quality and strength of the mortar would be. During the maturing process, it was stirred periodically. To prepare the mortar, a filler was added to the slaked lime, usually clean river sand. The proportions of lime and sand were carefully selected depending on the purpose of the mortar. The mixture was diluted with water to the desired consistency. This lime mortar had an interesting property. It hardened very slowly. This was both an advantage and a disadvantage. On the one hand, it allowed bricklayers to take their time and carefully lay the stones, adjusting their position. On the other hand, fresh masonry was vulnerable and required time to gain strength. The mortar hardened as a result of a reaction with carbon dioxide from the air, gradually turning back into limestone. This process could take decades, but in the end, the masonry became monolithic. Medieval scaffolding was made exclusively from wood. Long, straight poles were used, which were fastened together with ropes. Nails were rarely used for this purpose, as rope connections were more flexible and allowed the structure to be easily dismantled and rebuilt. There were two main types of scaffolding. The first, simpler type, was an independent structure that rested on the ground and stood at a certain distance from the wall. This type of scaffolding was used in the construction of buildings that were not very tall. For the construction of tall cathedrals and castles, a more complex so-called plug-in scaffolding system was used. It was integrated into the wall itself. This method saved a huge amount of wood and created very strong and stable structures at great heights. The principle was simple. During the masonry process, bricklayers left square holes in the wall at equal distances from each other. The ends of horizontal beams, called put logs, were then inserted into these holes. The outer ends of these beams rested on vertical posts, and the entire structure was reinforced with diagonal braces for rigidity. Wooden decking was laid on top of the put logs, allowing workers to walk on it and move materials. As the wall grew, the lower tier of scaffolding was dismantled and moved upwards. This system was very effective. The scaffolding was firmly attached to the wall, which prevented it from collapsing. In addition, it allowed construction at any height by simply adding new tiers. After construction was completed, the scaffolding was dismantled, and the wall openings were either filled with stone or left open. Let's take a look inside the toolbox of a medieval builder. We won't find electric drills or angle grinders there, but we will see a set of simple tools that are perfectly suited to their task. It was their masterful use of this uncomplicated arsenal that allowed them to work wonders. The mason's main tools were a hammer and a chisel. There were dozens of types of hammers, from heavy sledgehammers for rough work to small mallets for precise fitting. Chisels also varied in size, from wide ones for leveling surfaces to narrow ones for carving ornaments. A compass and a square were used to mark stone and wood. The square allowed you to construct perfect right angles, and the compass allowed you to construct arcs and circles. With these two tools and a simple string, it was possible to construct any geometric shape, even the most complex ones. A plumb line, a simple weight suspended on a string, was used to check the verticality of walls. Gravity was the most reliable indicator, and the plumb line could not be wrong. The horizontality of surfaces was checked using a spirit level or water level. It was a simple wooden trough filled with water. The surface was considered horizontal when the water in the trough was level with its edges. Hand drills and augers were used to drill holes in wood and stone. This required enormous physical effort, but allowed for precise and accurate holes. A tube with abrasive sand was used as a drill for stone. Carpenters actively used axes and adzes in their work. The axe was used for rough woodworking, and the adze, a curved blade similar to a hoe, was used to level and smooth the surface. An experienced carpenter could level a beam almost to a plain state with a single adze. Of course, there were also saws in the arsenal. Both large two-handed ones for sawing logs and small bow saws for precision work. Planes were also used for planing boards, and chisels for hollowing out grooves. All these tools were made of iron and wood and were forged by local blacksmiths. They required constant sharpening and maintenance, but in skilled hands, these simple tools became an extension of the craftsman's mind and will. The history of medieval construction is a story of how limited resources give rise to boundless ingenuity. It is proof that the human mind has always been and remains the main construction tool.